In this problem, we're going to solve an absolute value inequality. We want to solve the inequality, the absolute value of 2x plus 3 minus 4 greater than or equal to 3. We're going to express our answer in set builder notation or interval notation and then graph the solution set. The first thing we want to do when solving an absolute value inequality, much like when solving absolute value equations, is to isolate the absolute value portion. We're going to do that by adding 4 to both sides of the inequality. So give us the absolute value of 2x plus 3 is greater than or equal to 7. Now that we've isolated the absolute value portion, and we see that the absolute value inequality involves a greater than, we're going to split this up into two linear inequalities. We'll have 2x plus 3 less than or equal to negative 7, or 2x plus 3 is greater than or equal to positive 7. We're going to solve these two linear inequalities. We'll subtract 3 from both sides to get 2x is less than or equal to negative 10. Same thing here. We'll subtract 3 from both sides. We'll get 2x is greater than or equal to a positive 4. Divide both sides of the inequality by 2. Give us x is less than or equal to negative 5. And if we divide both sides of this inequality by 2, we'll get x is greater than or equal to 2. In set builder notation, our solution set would be a set of all values for x such that x is less than or equal to negative 5, or x is greater than or equal to 2. In interval notation, our solution set would be written as the interval negative infinity to negative 5. Use a parenthesis on negative infinity. We're going to use a square bracket on negative 5 because the inequality is not strict. It'll be union with the interval 2 to infinity. Again, we use the square bracket on 2 because the inequality is not strict, and we use a parenthesis on infinity. The last thing we need to do is graph our solution set on a number line. So we'll go ahead and use 0 here in the middle. We'll go on a scale of 2. So we'll do 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. And we had two parts to graph. We have to graph negative infinity to negative 5. Excuse me, negative infinity to negative 5, including negative 5. And we're going to draw an arrow that points to the left, indicate this goes to negative infinity. We also have the part 2 to infinity. We'll put a square bracket at 2. And we'll draw an arrow to the right, indicating this goes off to positive infinity. And there's the graph of the solution set for our absolute value inequality.